All right, so in part 2, I'm going to work on problems 4, 5, and 6 and see if we can't find out if there's anything unusual about these problems in terms of the law of sines. All right, so a building 30 feet high is on top of a hill. The angles of elevation to the top and bottom of the building as viewed from a point on the foot of the hill are 63 degrees, and 60 degrees respectively. How high is the hill? All right, so we are going to have some kind of hill, all right? Again, I'm not worried about your drawing, other than you get the right information in the right place. And then on top of that hill, we have a building that is 30 feet high. All right, now we've got some kind of, and I'm actually going to make this hill a little bit different looking, just because, there we go, something like that. All right, so the angles of elevation to the top of the hill. Now, this is where I want to actually fill in some information. So I'm going to assume the building is perpendicular to the ground. Okay. So this is where I'm going to fill in a little right triangle here. So this angle to the top of the building is 63 degrees. And then this angle to the bottom of the building is 60 degrees. All right, so based off of that, I'm also going to I'll just slide this over. I'm going to move this 30 feet over so I actually know what's the height of the building. And it says, how high is the hill? So X goes, whoops, actually right with a pen. There we go, X goes there. All right, this is very similar to, I think, one of the other problems that we did. So take it apart in pieces and let's start finding some angles. This angle right here is going to be 30 degrees. So that's a 30, 60, 90. If this is 30, this right here, this obtuse angle is going to be 150 degrees. Keeping in mind that 63 belongs to the big angle, so from the ground up, not just the little itty bitty angle right there. And that little itty bitty angle is actually a 3-degree angle. It's the difference between 60 and 63 degrees, so that's 3, which means I think I'm going to double check on my calculator because I don't feel like making a mistake right now. I believe, 27 degrees. Okay, so I have filled in all of the possible angles now. And remembering that I want to find X, well, I either need to find this base down here across the ground. Not sure I can do that easily. But I do know enough information about this triangle right here to find this height. This hypotenuse is what I should call it. H for hypotenuse. So let's go ahead and fill in H here. So let's see. H is opposite the 27-degree angle. And 30 here is opposite the 3-degree angle. So using those 4 pieces of information, let us set up a law of sines. So sine of 27 over H is equal to sine of 3 over 30. So let's see, H, whoops, that is not an H. H sine 3, 30 sine 27. Go ahead and divide both sides by sine 3. And I'm just going to use the calculator that's sitting next to me on my desk. Always make sure that you are in degree mode for these problems. So H is 260.23 and some more stuff. So now that I know H, I can reset and work on the little right triangle that has the height of the hill in it. So if I reset, I'm going to go ahead and use 60. So I know this reference angle of 60, I know the side opposite is x, and I know the hypotenuse is h, which is this 260. So sine of 60 is equal to x over h, which means x is equal to h sine of 60. So on my calculator, I'm just going to do times sine of 60. Let me see if there were any rounding directions. There were not, so 2 decimal places unless it says otherwise. So 225.37 feet. Obviously, my picture is not drawn to scale, and I'm not going to worry about that, okay? So I'm not worried about the scale if the picture. What I will be taking a look at is the information from the problem in the right place on the picture? That's what I'm going to care about, okay? All right, problem number 5 is kind of similar, okay? And I'm going to keep zooming in so I can see the whole thing. All right, TV antenna sits on top of a building. So we have a building, and here's our TV antenna. From a point on the ground at a distance of 75 feet away from the base of the building, so there's 75 feet, a person determines the angle of elevation to the bottom of the antenna to be 48 degrees. And the angle of elevation to the top of the antenna to be 54 degrees. So this whole angle from the ground up is 54 degrees, okay? We're going to assume that the building is perpendicular to the ground, and it's asking for the height of the antenna. Now, this one, I would absolutely still start in the same place of filling in some angles. So I'm going to zoom in on the picture. All right, let's look at just the little right triangle. So 48 here, a 90 degree here. This should be 42, but I'm going to double check. And it is 42. Okay, so this angle is 42. Supplementary angle sitting next to it is going to be 138 degrees. This, and I'm going to mark it in orange, this angle, the little one right here, is going to be the difference between these two angles of elevation. Difference, remember, just means to subtract. So 6 degrees there. If this angle is 6, this angle is 138. So let's do a little subtraction. And so this angle up top here is going to be 36 degrees. Okay, so I filled in all my angles. Now, this is where, again, there's a couple of options here. I think there's one that's the easiest option. And the easiest option is probably going to be to find the hypotenuse using the right triangle. We know the reference angle. We know this adjacent side. We can use that information to find the hypotenuse. And then once we have the hypotenuse, I can set up a law of sines problem to use the hypotenuse, its opposite angle, the height of the antenna compared to its opposite angle. So in this case, it's a little different because we're actually going to do the right triangle trig first and then apply law of sines. So let's see. I'm going to do cosine of 48, which is equal to its adjacent side of 75 over the hypotenuse of h. So a little cross multiplication, and you would get h is equal to 75 over cosine of 48. Yes, I did a couple of steps there. It's okay. All right, so 75 divided by cosine of 48. So h is equal to 112.08 and some more stuff after that. So let's see. All right, I know h. Its opposite angle is 36 degrees. And I want to use this 6-degree angle with its opposite side of x. So that's going to be the law of sines problem I'm going to set up. So sine of 6 over x is equal to the sine of 36 over h. So let's see, h sine 6 equals x sine 36. So x is going to be h times sine of 6 over sine of 36. And remember, this h value is the same thing that's sitting over here as 112.08. And again, there's more stuff after it. I'm just leaving it in my calculator so I don't drop decimals. That's all it is. So on my calculator, I'm going to take that answer, multiply it times the sine of 6, then take that answer divided by the sine of 36. And I am getting an x value here, so the height of the antenna, and I'm going to zoom out just so I can see no rounding directions. So round to 2, please. 2 decimal places, so 19.93, and I'm looking really quickly. I think this was in feet. So the TV antenna at top of the building is 19.93 feet. All right, last problem for this video is going to be problem number 6. Let's see what we got here. Motorist traveling along a highway at a constant speed of 60 miles per hour directly toward a mountain observes that between 1 p.m. and 1:10 p.m., the angle of elevation to the top of the mountain changes from 10 degrees to 70 degrees. Approximate the height of the mountain to the nearest whole number. All right, so we have a mountain. All right, I'm not worried about it. We know that we're going to figure out this height. So there's my x. And we have, let's say, a road, and we have this car that is looking up at the top of the mountain, and this angle is 10 degrees. The car gets closer, okay? It's driving towards the mountain. And it notices that the angle of elevation changes to 70 degrees. How tall is the mountain? Okay. Height is always figured out perpendicular to the ground. So that's one of the reasons why we have to use approximation methods with things like mountains and other things, because you don't have a way to measure it, using a ruler or something like that. One thing to keep in mind, there's going to be a little bit of logic. If you are traveling 60 miles per hour and 10 minutes have passed, 60 miles an hour means you are traveling 1 mile per minute. There are 60 minutes in a mile. No, try that again. 60 minutes in an hour. Wow. So 60 minutes in an hour, 60 miles per hour, you're moving 1 mile per minute. So if you travel for 10 minutes, this distance from where you initially observed to the new observation, this is going to be 10 miles. Now, if you don't have nice round numbers, you can always, and I'll put this off to the side, take your speed, your rate, times your time, which in this case is 10 minutes out of 60. Okay. Now, the reason I put it, because you need to have, if this is miles per hour, you need to have your minutes in terms of hours. So 60 minutes in an hour, need to do that conversion. If you do this, this will turn into the 10 miles that I was talking about. So again, if you had something like 50 miles per hour, it's not as easy to figure out. You're not sure exactly how many miles you're going per minute. Set up a fraction and a ratio to do that math for you. Okay, so what I'm going to do is zoom in on the picture, and I'm going to spend a little bit of time filling in some angles. Always good practice. All right, so if this is 70 degrees, 90 degrees, this angle up here is going to be 20 degrees. And be careful that you're not confusing yourself with the mountain triangle. And so that's where you might just want to put a height and just say the mountain is perpendicular to the ground. That's fine. I know that this angle adjacent to the 70 degree is going to be 110 degrees. 110 and 10, and this angle up here is going to make another 180. So what would that be? 100 and, no, that's just 60. So this angle right up here, I will put it in red, I guess. That should be a 60-degree angle. Okay. Yep, looks good. So I need to figure out x here, which is the height. I know this 10. Again, this is probably a place where I'm going to find this hypotenuse and use that information to then find some other pieces. So be careful how you set it up. This hypotenuse is opposite to this 10-degree angle. And then this 10 miles is opposite to this 60-degree angle. So let's set it up. So sine of 60 over 10 is equal to the sine of 10 degrees over h. Let's see. H is going to equal 10 sine 10 over, that is a horrible S, sine of 60. Into my calculator that goes. All right, so H is equal to 2.005 and some other decimals. And now that I have that, I can use this littler right triangle with either the 20 or the 70 to find x using the hypotenuse. For giggles, I'll go ahead and set it up with sine. It won't matter if you use sine or cosine, depending on whether you use the 70 or the 20. It's up to you. So sine of 70 is equal to the opposite side over the hypotenuse. So x is going to equal h sine of 70. So on my calculator, I'm going to multiply my hypotenuse times the sine of 70. All right, find the height of the mountain, round to the nearest whole number. So x is going to equal 2 miles. All right, so our little mountain here is 2 miles tall. All right, any questions on 4, 5, or 6, please let me know. If you're setting these problems up and you're struggling with them or you're trying to solve them, any questions you've got, bring them to Zoom, or you can always send me an email or a Canvas message.